Okay, looks like I'm about to be online here. Just waiting a few seconds for my YouTube live channel to update. There we go. I am now live. Oh, crap. I've got to do that before this will work. There we go. And now I'm live. I'll put that over there, I guess, for now. Okay. Okay, so in this live stream here, what I'm going to do is I am going to be going through another C library update along with a few other things. Because right now, what I want to do is I want to get the the listening part of networking to work correctly. So the other day I had the server code started, but I didn't actually properly go through and test it. But right now I am going to write the code that actually lets you not listen, but lets you connect to a port. So we're going to go export connect, and then I'll just put this down here. Proc connect near and proc. Okay, so now I have to design the API I need for the connection. So what I'm going to do here is we're going to create a new C file called echo client. So we're going to go new file. I'm going to call this echo client.c. So this will be able to test out the networking code. So let's take a few minutes here, because that always opens up an external editor. I've got to fix that at some point. Okay, so here is our echo C code here. So what I'm going to do is we're going to do a include stdio.h. I also need to do include clib/heos.h, and then do int main okay. And now we're going to go into our clib/h. I recently created this file here. This is a brand new file, and you can actually download the dev kit stuff yourself right now as well. I just put all of these things up into a repository. Let me just bring that up for 1 minute here for you guys can see where that is. 1 second here. So if you just go to hackersedge.com/he, or sorry, not he, I just go to DevKit, and you'll get this nice location here, where you'll have access to the README file and a zip file that contains everything in this directory here. So you'll have a make file and a bunch of other stuff as well. You'll still need to have CC. You'll still need to have the CC65 though in order to make that work. So we go we need to do extern. So let's go char connect. Okay, this is going to be interesting now. So I need to be able to also convert the IP address into a proper integer, because an IP address, I believe, is a 32-bit integer, because you have it would be a 32-bit integer. So I wonder, does this support 32-bit integers? I think it does. Yeah, I believe it does. It has sreg, so I believe I can send back a 32-bit. I can send in 32-bit ints. It seems. So the systime function I can look at here, because I'm not too sure exactly what CC65 calls a 32-bit int. So let's go to the documentation for a second here, and let's take a look. So I believe it's under time.h is where I want to go to. And then go to time. it actually returns a time type. That doesn't really help very much. So I don't really want to use a time type. And there's a clock type. So that doesn't exactly help me right now for what I wonder if I need to create a new type maybe for this to work. Because there should be it should have 32-bit types though. Okay, I'm going to go into my CC65 directory here. Just 1 second. CC65. So I'll bring that up right now for you guys can see where I'm going because I don't want it to be too empty here. So here's the CC65 directory listing. So where I want to look to find if this is there is we'll go into include first, and I will go into just go into time.h here and see. This time.h should display what I want. Okay. Looks like so the type is just called unsigned. Okay, unsigned long is what I want then. So that's pretty simple. So unsigned long is what I want for this. Interesting. Okay. So unsigned long is what I'll want for IP address. So what I'm going to do is I'm actually going to type def this as well. So let's actually I'll keep this just in case I need that for later reference. So I think the best bet to do would be to go up here and then go type def unsigned long IP address. So now we have an IP address type. So then we want to send this in as a constant. So constant IP address. So it gets sent in entirely as our unsigned long. And then we want a port number. So we're going to go char port, rather than being a byte, but I'll work that out later. And then we also needs to have an int of address as well. We need our address for our callback to there. So I'm going to check something here. Okay. So now we have our connect function, and then we have our unsigned long IP address, which is where we want to connect to. I should also eventually make a function to allow enabling to get the IP address as well. We'll do that later on. So now our Echo client, we need to be able to connect over. So what we're going to do here. Oh, the other problem is that there's no actual function in CC65 to convert IP addresses to unsigned longs and vice versa. So I'll actually have to create a new function as well inside my net.io, or no, actually no, I can just create it in C, because it'd be a lot easier that way rather than creating it in there. Or actually no, from my understanding, I believe I actually wrote a function to convert them over, didn't I? Actually, I don't know if I have that function, but I can, because there's a function I did write, but I don't think I have it. Yeah, I'm trying to think now if I do. Let me see here. So let's go into Game Engine here. Let's look at my devices and look at the NIC device here, because I don't think I wrote that function to do that. So if we go down through here, so this one doesn't have that. I don't think I actually put in the NIC device directly, because it doesn't make any sense. I believe it's in the API access. If I do have it. Yeah, I think I was gonna write it here. It looks like. Maybe not. I don't know. This looks. No, that's the hex. That's the hex dump. Oh yeah, I was gonna write hex dump. Yes, I forgot about writing that program. I was gonna write a hex dump tool. I was thinking of writing it in C2 now, because C it'll make it easier. So that way it's in C, and I don't have to worry about using its proprietary API calls for those things. But anyway, so I'm going to need to actually write a function here in my... I'm going to try writing it in C here. So I have to go into my CLib and write a new file called, let's see, iplong.c. So this code here will convert it back and forth between convert the IP address between a long and a string. So that way we can send in a string to say to not connect, but send in a string to get a buffer to be able to convert our IP addresses back and forth between a long and a string. And that is actually how it works in real life as well. If we look at networking software, like you don't really send in a string IP address. Programs actually in the background actually convert it over for the socket layer. So it's a 32-bit int. So for this function here, this is going to be a different library function. So let me see here. I do believe I am going to need standard lib here, because standard lib has a bunch of other routines that I'm going to need. So, I'll also have to include, actually no, because it's going to be in CLib already. So we're going to go include heos.h, because I want to be able to have this IP address field here. So what we're going to do then, we're going to go ipaddr. So no, because there is an I2. Oh wait, no, that's not what I want. I need, what's the function called in C actually? There is an actual function called. I'm kind of curious what it's actually called. Let's see here. C. Okay, in C, it's called. There we go. Oh, it's very similar to. It's called N to A and A to N. Okay, so this is going to be. A to N. I believe it's for network and ASCII. Yeah, A to N, so network. So we're going to turn ASCII into network. So then this function needs to take in a pointer to a char. So we're going to go constant char and IP address. I should probably just go IP address. Actually, maybe I should do that just for mess myself up here. Let's go IP address T, because that's more of the standard. So let's just do that now before it gets too confusing and I end up breaking things. There we go. Okay, so IP address T, A to N. Okay, so we need to get that. So we need to go through each character on the input, and then basically convert it to a long. Okay, let me see here. Actually, I wonder if I can get the source for the C version. inet, because I'd rather not reinvent the wheel if I don't have to. There we go. I want to rather view it in the browser, but all these sites are wanting me to. Oh, there we go. This works. N char constant. N. Oh, interesting. So in their version, they actually do have it as. And they have it as a struct actually as well. Interesting. But I don't know if I want to do it that way for me. I guess I could technically, but oh, that's easy. Is it comments or that's weird? It doesn't look right. These are like pipe characters. It looks like maybe they are comments. That's I don't know. That's weird. Dot zero. What's that? Store. Yeah. What the heck? This is strange. Oh no, this is. Oh, it's a tab character. Oh yes, that's okay. It's a tab character. Okay, that's weird. So that's just interesting. So that do. Huh. Wonder why it needs all that. Maybe it's just trying. Maybe it's trying to. So you would think all I would need is just to do this part here, because this will automatically convert it. It looks like to the address I need automatically. But oh, it's a struct though too. So maybe that's why. Maybe that's why it needs this, because it's getting the address. Because here, yeah, where's address declared? Oh, there it is. Okay, register long unsigned long. Address is 0. Yeah, okay, so 0 makes sense. And then it's just normalizing the address. I don't see why it's doing anything else differently. I might create before I compile this into my library, I might first build a test program just to make sure I can get it working correctly before So let's go here. Let's create a new test C file where I can just put anything I want in it to test things out. Of course, it's going to take a minute to load up my. There we go. And try again. Okay, so I know I'm going to need include stdlib.h, and then include conio.h for my puts. And I don't think I need to import my HEOS because nothing in there I really need for this. And then go int main. Okay, so let's create a few strings now. So I need my character buffer. So char IP address, because that does not have a, okay, so I'm going to have to figure out how to assign that as well, right? Okay, then we go actually I'll just put the type, actually I guess I will need HEFS, yeah, I guess I will need that, so HEOS.h, because I'm going to need to test out my type as well. So IP address T is I just call it IP long for now. IP long, which I will set this to. Let me just generate one over here in Python. So we're going to go IP equals. So here's how I'm doing it here, just so you guys can see. I think there's a function in Python as well that I could just use from the sockets library. Yeah, there is actually. Let's just import sockets. So I don't have to worry about doing it myself then. So socket dot ASCII to N. Nope. There it is. Perfect. Okay, so let's just go 64, be 7, 23, 88 as an example. There we go. I want to know which direction it is, though, because it's the direction I'm using, or no? Yeah, it is. Okay, good. It's the right direction. Okay. So, but I need it to be a proper long, though. So I need to convert that over. Import struct struct dot unpack long. Oh, guess it's okay. There we go. so now this number should be what I should be. This I should be able to convert back. So when I run my test program, I should be able to output that number. I should be able to output the same IP address that I just entered in if it all works correctly. If this is going to work. So now let's try writing my code here. Yeah, because I'm going to write the code that converts a number into that. Or wasn't it? Oh yeah, I was going to do this way first. I guess I'll do it that way first. It shouldn't matter too much. Okay. Okay. Let's see here. Yeah, because I need to be able to. Let me see 1 second here. That's not right. Oh, it needs to be. Okay, that's my problem. Okay, I got the code I need because I should be able to do bit stuff in here. So. So I don't do C enough that I don't do C as much as I'd like. I'm trying to remember how to, because I need to allocate the pointer in order to allocate that character pointer in order to be able to do that, in order to be able to work with it. I want to see if the CC documentation has anything. I think it's going to be, if anything, it's probably under standard lib, I'm guessing. Let's see here, standard lib. Because we have okay, I think okay, so memchar. No, it's not it. Okay. So I'll have to do memalloc. I'm going to use memalloc to do this. So we go IP address equals char malloc allocate. We need to allocate, I guess, 5 because we'll have to have the null at the end, and then we need to make sure I need to make sure I free it, I guess. So we're going to go free IP address afterwards to make sure I freed it up. If I don't free it, then well, it's not going to work very well. Okay, so now that I allocated it and I'm freeing it, now I need to be able to. Maybe I'll do a quick test here just to see if I'm doing this allocation right. So then now IP address equals. Let's go. Oh shit! Pardon my language. That makes no sense. Let's go at least 30 maybe. Oh god, okay, let me see here. So 4. Okay, let's go 20 should be more than enough. Just want to make sure you don't get buffer problems. Okay, so let's do 24, 33, make sure this works correctly, and then do a puts IP address. I believe I can do that with this. Okay, so this should put the IP address out, and then free it. Make sure this works. I gotta start learning C a bit more. I'm not as good with C as I'd like to be. It's a good rhyme. Okay, so game server ASM. I guess I could call it ASM. I guess test.bin. Huh. That's strange. No rule to make test.bin. Oh, oops, I'm in the wrong place. Oh, crap. And guess what? I also did not put my file in the right place. So let's go move test.c into here. And close it. I put it in the wrong place entirely. It's lovely. Test. Oops, I gotta delete that, I guess. Yeah, I was just testing out network driver stuff. Okay, so where is... Oh yeah, I gotta... F5. Okay, there's test.c again. Okay, and I gotta remove test.s. Make test bin. Converting integer to pointer without cast, 9. Converting integer to pointer without a cast. Converting integer to pointer. Huh. What? I need to learn C a lot more. Especially if I want to be able to do this. Control reaches non-void. Okay. Call to undefined. Oh, oops. I thought puts was in con.io. Guess it's not in con.io, is it? Okay, where is puts then? If it isn't in con.io. I really thought con.io would be the place for puts. Okay, no. It's not in con.io then. Okay, where the heck is it? Puts. Or is it cputs? Wow, it's been so long since I've been doing all. No, it's puts, and it's in standard IO. Okay. I don't see it in their documentation for being in standard IO, but if it's in standard IO, then that's where it is. I swear their documentation's out of date here. Where is it? Standard IO. Yeah, I don't. Oh, it says incomplete there too. So, anyways, so let's try making it one more time. Make sure I get that. Okay, so I still get the warning for the pointer that I cast, but I'm still going to try running it and see what happens. So, whoa. Segment code overflows memory area What? That can't be that big. Wow, that's strange. So I got a warning here. Code overflows memory area code segment by 290. What the? How much memory? How much does this take? It's crazy. C programs are crazy big, it seems. So let's modify my code segment here. Let's go 600. Test O, test S. Okay, so now it built it. Now it did build it correctly, and it dumped it into. Oops. I need to recopy that over afterwards. Okay, so I'm going to do a make clean here. I need to actually boot into my localhost 137. Okay, so hosts. So I believe F5 is my hotkey for that. Perfect. Okay. So now let's do make OS. Make OS. Yep, that's it. Okay, so make OS. Got bootsys. Got all that. All right, now I should have ls working. Yep, perfect. Okay, next I can do make test. Now I should have test. All right, so this is still going to break. Oh, it didn't. Beautiful. Okay, so that's good. So I did my code right then. So my pointer obviously works nicely then, because this was stored on the heap, and it looks like the heap code worked. Although, okay, good. Everything still works and functions. So that's good. Okay. So now that I know that that works correctly, and I wouldn't mind figuring out creating integer to pointer without cast. Although it's only a warning, I still don't like warnings. Warnings are just not pleasant. I know how to fix the bottom one, obviously, is to do a return. But this one is just a little annoying for me. Converting integer to pointer without cast. Let's find out here. So converting integer to pointer. Converting integer to pointer. Is it this here? I'm really wondering now. I don't think it's that one, but I'm having my guesses it might be that. Let's go to malloc. No, because converting integer to pointer, because size t is not a pointer according to this, but I am wondering now where. Do I have to do that, I wonder? Well, let's try something. Let's do return 0. Okay, let's see if I get any more. Oh, that fixed it, apparently. So that got rid of my warning. So I had to put the char star, but now does my program still run? Or does it run better, more efficient? Yeah, it still runs. Okay, cool. Nice. Okay, but I also am kind of curious on how this works now. So let's do make test.s. So let's take a look at how it runs here. So let's take a look at test s. This is what this C code generates. Because when I take a look at how all this works, it's always interesting to me to understand how all this. So the program itself is pretty small then, but okay. So let's take a look here. Okay, so here's the call to memory allocate, right there. This is what uses the heap, I believe. So we go ldx. Okay, so this here is the number that I'm writing to, my 16-bit number, and this is what pushes it, my 16-bit number in. Then we do LDX 0, and then LDA 14. That's my point. This is my pointer here. Oh no. This is the size. 14 is how much I want to allocate. And then we go to memory allocate, and then what comes back is LD and LDY, and we store it into here, it looks like. So, oh, that's this. That's that right there. That's that string. So that I'm taking that string and then do LDY again, and then we do JSR STXYSP, then we do 5, and then we do free. So 5 appears to be where my pointer is. So 5 is where my pointer is then. Yeah. Okay, so that's interesting. Yeah, the program itself is quite short, as can be seen. But I'm wondering now. The int lib code inside the clib. Yeah, the int lib code here is what initializes the heap, so that should be fine. Okay, so I want to just remove test.s now for when I rebuild it again. I can test that out properly. Okay, so now what I want to try and get is I want to try and get an IP address from this number and store it into here. So what I need to do first is I want to store nothing in it, just to make sure it's empty. Actually, I wouldn't mind doing some. Actually, let's try something out here. I want to see here. Puts string length, str length, IP address. I'm wondering now. This isn't overwriting the pointer information, I don't think, is it? Yeah, because I'm not dereferencing this. I'm not dereferencing this, so I'm kind of wondering if that might be what's going on. Oh yeah, string length is in strings.h, I believe. I don't think I can do that, print it out directly though, like this. It's going to complain because, I can't include string.h. Oh, converting integer to pointer without a cast. To pointer, yeah. So I can't just do that. What I need to do is I need to do should be able to put the buffer out, the buff. I should be able to put it all in one line technically, but that's why I can't put it in one line, because it's not a function call. There we go. Huh? Too few arguments? Huh. Let's see here. Oh, yes, okay. There we go. Okay, now, so this should return back the length of the string if this is correct. 11. It looks right. Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep, it's working. It is correct. So my heap allocation works, and it's able to get the string length of that IP address. My only worry is, though, is where it's assigning this to. Because I don't know if it's overwriting the pointer, or if it's sending it to where the pointer is. Because I'm not dereferencing this, right? So I'm not entirely sure. Because in some languages you have to dereference the pointer. So I'm not too sure if I'm doing that correctly or not. I don't even know if there's an easy way to find out without scanning through the memory. And I have to know where the heap is located in order to do that. Actually, I can probably find out where the heap is. The heap, I believe, would be after... Ooh, I know what to do. Here's something I'd use for debugging that I don't really show too often in here because it's not something that I normally do. Okay. Okay, so there's a nice tool called hexdump that I can use here. So if we go 49.67 and 49.67.30.2, and then we can do memory, and then enter. So this will tell me exactly the memory structure of the virtual machine. This is the dump of the memory, which is kind of cool, actually. Oh wow, the file buffer is still there from before. Lots of information to look at. Anyway, so let's see here. So I'm looking for my code at 800 here. So here's 800. Wow. The C program's quite the length. So I should see this twice, correct? Yeah, I should see this twice. Once where we have this, once in the static, in the actual code, and then in the heap. I only see it once. I only see it once. That's not what I expected. I wonder if I can get I should be able to get the address of the heap, though. I want to find... I think there's some code I can use to get the heap location. No, I don't see it here. No, I don't see any code that will tell me that. Any C code. Okay, let's see here. Because if I go into, actually, where is my CC65 source code here? So here's CC65 code again. Let's go to underscore heap. Let's take a look here quickly and just to see if there's anything here that might be useful. Free block. So here we go. So variables that describe the heap. So I should be able to import heap.h, and I should be able to look at heap org. So heap org should tell me where the heap is, and then I can look inside my code to find out where I need to go. So heap org. So let's do that then. So we need to import, not import, include heap.h. Okay, and then I need to be able to output this as a hex. So I'm going to go, let's do this actually. So underscore heap org, and then we output it as 16, and then puts the buff. Save. Make test bin. Test. Okay. So our heap org is at 32F. So now I can bring this back in, and we can find 32F. So that's definitely not it. It's in the 3s. So it should be right here. I should be seeing a string right here that is the heap. That would be my what I'm looking for, but I don't see it there at all. Instead, I see it here. But this, I believe, is my code, is my static code, because my code starts at 800. So the C program starts here, and then this is the static code. This is the read-only code at the end. These are like the read-only stuff here. This is the constant. Huh. So I'm not too sure what's going on there then. Well, I am freeing it. I wonder what happens when I free it. I wonder. Let's try something. Let's do cget c. I'll probably have to do a con.io for that to work, though. Right? Yeah, I need con.io for that to work. Okay, so let's take a look here. So run test again. Okay, now it says 32F again. So now let's look at another memory dump. Enter. This is it actually running. So now if I go to 32F, I should be able to see I don't. And the only instance I see is still here. Because this is the kernel, this is the network driver, this is the file, there's the shell code. Yeah. Then I'm doing something that I'm obviously doing something wrong then. Because I'm writing the heap, but I don't see it in there. So I don't think I'm dereferencing it correctly. Because I think you do have to do a string copy for this, because I think I'm assigning this correctly. But then how is the puts putting it then? That doesn't make any sense. Puts shouldn't be able to be putting the IP address out at all then, right? unless I'm overwriting the pointer somehow. But then I don't even see, or I am overwriting the pointer, and that's why. Because I'm wondering now what that code is there. Oh, no, because it's a constant. I should still be seeing it twice in memory. This is really confusing me here. But let's try this. Let's do a string copy. Technically, I shouldn't need the 0. There. Okay. Okay, it's 32F. It's still 32F. Let's dump it again. Let's see what happens now. The heap is there. I should be able to see it now in the heap at around 32F. There it is. Okay, so I wasn't doing it correctly. That's lucky that I'm checking these things, or else this would have just totally not, or else I would have totally broke everything. So I have to do a string copy there, obviously, right? Because if you do an equals, then it definitely overwrites it. Oh, weird. 32F. Why is that up there in 0, 0? Yeah. Why is that in the 0 page? That's that's undefined behavior. Because the 0 page is for some reason being used as my output buffer for my C code. Oh my! I wonder now. Okay. Oh, that pointer is null. I didn't initialize the buffer. That didn't even warn me though. I never initialized the buffer. Which explains why 32F's up there. Holy fuck. Oh, pardon my language again. Jeez. That's, oh, wow. Ah, this is interesting. Okay, so yeah. This is good learning. Let's go 20 for this buffer as well, just to have that buffer good. And then we have to, and then free the buffer, of course. Oh, gee, that's so funny. That obviously means there's a few other programs too that I might be messing up on. Okay, now if I run it, now I should not see 32F and 0. Actually, I will but I should see it in the proper location now. Yeah, there it is, 32F. See, if you have uninitialized pointers, then well, you're gonna really mess things up. Goes to show, it's gonna use the 0 page. So, yeah, so that's interesting to know, to keep in mind. Okay. Okay, so now that that's all good, yeah, that's lots of stuff to keep in mind there. Let me see if I have any chat stuff on the live chat. Nope. Okay, oh, my stream output looks a bit bad right now, it seems. Hopefully it's not too jaggy for people watching right now. Okay, so this video is going on to about almost an hour now, and I haven't really gotten much progress besides just kind of learning a few things about how to properly do C coding and not have really bad bugs. Okay, so at least now I know what I'm doing right and what I'm doing wrong with my code here, so that's definitely good. So now that I know, okay, now let's get back on track to actually writing my A to N code. Oy, okay. Okay, so first I want to try converting this over to the other one first, just to. Okay. Okay, so let's get rid of my buffer now. Let's get rid of everything I don't need that I just created just for the. Okay, so now the code to do the IP address, we need to do I need to go. Okay, so I'm not entirely used to C4s yet entirely, so we need, actually I can just do int without the 0, I don't need that. That's a good point. Okay, so we go dots equals 0, and then I think the iterator is, oh no, the if is next and then the iterator. So we go dots is less than 3, and then dots plus plus. And then the function for appending this the string, trcat, I believe. Yeah, I can concatenate two strings. Okay, good. Okay, so I'll also need a proper buffer though. Int dots, and then we also need it to be a temp variable. So we go temp equals IP long, and I think I can do that in here. I wonder if I want to do a for loop here, if I just want to not even sure it's going to properly work though, but try this first, just to see what happens there. Oh, I got lots of warnings. Okay, invalid character with code, invalid undefined symbol. Okay. So I thought I could do maybe in C it's like this. Let's find out. Okay, that worked. Okay, so warning, error. Okay, and let's take a look. So 17 and then 18, converting integer to pointer without cast. Okay, so 17 and 18. So this one's fine apparently. 17 and 18. I'm wondering now. Why would this be there? Let's convert integer to pointer without cast buffer. Oh crap. I have to allocate the buffer. I guess I should have just kept my other code. Code's just growing and growing. I might be better just using a, because this program is going to be too big. Yeah. Okay, that's a problem. It's 1.6K. So yeah. So I think the best bet in order to keep programs small, because if I make it in C, if I make something like this in C to be able to convert the IP address over, and that is going to just cause a lot of problems. I'm going to try running it just for the heck of it. I'm sure it's not going to work, but I think I'm just going to put this into the internal API, or else programs that have to do network calculations are going to be, yeah, it worked. Without the dots, but it worked. So 64. Yeah, so there's all my digits there. So, yeah. Yeah, 40, 38, 16. Yeah, wow, it worked perfectly. But the program code is just way too big to convert back and forth, obviously, because I have to do so much. Yeah. So I think the best bet is to actually code it into the internal HE API, like I was going to at one point. So let's do that. So HE API is going to include a. Let me just look at my stream here. I don't even know if people can actually see what I'm typing at this point. Nope, you guys can't. It's too low. Maybe no, you guys can't. Okay, so I'll put it over here for now. I'm starting to get hungry though, so I'm probably going to be going downstairs soon. So I'm going to put the some networking stuff at 40, at API 40. So. And then these are just going to do the conversion automatically, because I already have code in my NIC card. If we go over here, see, you see this is a very simple code that just converts it back and forth. It works beautifully. To be able to take it. right? So, okay, so it's going to be the same one as a while too. So we're going to have so f0 is going to contain the address of what we're going to be converting over, and then our dest is get set at 0xf2 is the word at 0xf2. So this one is going to take the IP address, take an IP address string pointed to from address, and then put it into dest. So, so what I have to do here is we need to go. Yeah, because that just gets the word. So we need to do. We're going to do, because I can't access this directly from the other one. Or actually, no, that's not correct. That's not correct. Yeah. Sorry. Self dot mem dot read. Read 4 bytes. And then we go self dot mem dot seek our destination, then self dot mem dot write and then you can take the code from here. There we go. Oh, that's why. Mem.seek address. We'll be able to seek at that address. And then we want to read 4, and then we store it there. Okay, good. And now we just do the reverse. PI 41. Might as well just copy it like this. Oh, I think that's a problem, because which one does which now? Ah, damn it. Okay, so 40 I was going to have as converting it to from a string to a number, right? From a string into a number. So this isn't right. IP address should not be this. We should be self.mem. Believe it's get string address. Let's go to memory just to double check if that's what I want. Yeah, get string. It gets a zero terminated string, which is going to be our zero terminated IP address, and then we seek to. Oh, actually, we don't need to do a seek here at all, right? Because this handles it all. We go address, we just go get address, then we just increment address entirely until we have it. Oh, actually, I could do set. No, because it needs a 0. So yeah, we can't do set string for that. So because we'll overwrite more than 4 bytes if we do a set string. so then we have the IP addresses of that, and then we do memseek destination, and then we just write the IP address. Technically, this means it could be more than 4. Okay, so then to convert it over the other direction, we do a memseek. We seek into our address. We're trying to convert it back over, and then we get our IP address. We get the bytes we want, and then we seek to our destination, where we want to write our actually, this is not exactly what I want to do here. Yeah. I'd rather use set string, because that way it's better. Set string, and then address, and then destination, and then we just need to take this code here, put it there. Okay, and then we don't need memWrite, and we can return 0. Oh, actually that would work. So, because we have it right here, so we seek, and then we do this, and it should work just fine. Okay, perfect. So 41 is to convert to a dot notation, convert to a string, and 40 is to do the other way around. Okay, so now instead of creating this c.ip long, we're going to close that out and delete that file. And we just go back into the clib, delete iplong.c, and go into net.io. Go into net.io, and now here at the very top, I'm actually going to put it here. So .export A to N .export and N to A. So then we go .proc A to N N to A. Okay, so how this works. Okay, I need to define my code here, so I have to go into my include file. So here we're going to go extern. Since it needs 2 pointers, we're going to go void, and we're going to go n to n to, oh no, we wanted a to n first. I had a to n first, so a to n. So we need the ASCII first, so we go constant char star is source, and then we go IP ADDRT is our IP address. And then void n to a constant char. Oh no. Constant IP address T. IP address. And then char star dest. Okay. Now I go into test C. I actually don't really want to delete this. I kind of like having this as a nice little example. So let's just create a new C file, unfortunately. Let's call this Let's test2.c. Okay, so next. H. Let's do this. Clib heos.h int main return 0. I should allow the return code to be sent back to the other program as well. Okay, so now we need to go. I want to go A to N and N to A, and it needs the IP address. Okay, so we need a buffer. So char star buff equals m alloc 20. And then, actually, no, I don't think I need this. I wonder. I should be able to just go IP address T, IP, and then do a N to A, right? That's what I wanted. Or no. A to N. And then let's go 24.120.43.89. Okay, so this should be able to convert this over to our number we want, and then I just need to do I do need a buffer, actually, don't I? Yeah, I do need a buffer. Char star buff equals malloc 20 char star cape, and then we go I to A, I to integer to ASCII. Integer is our buffer, it's our IP, sorry, and buffer, and then 10, and then we do puts buff, and then free our buffer. Okay, so test2 should hopefully give me what I want. Let's find out. So let's go make test2.s. Oh, I need standard lib. Okay, so standard lib. Hey, worked perfectly, no errors. Awesome. Oh, that's pretty good. Anyways, so let's go. Let's open up our S file here and take a look at how the calls work for this. Okay. Okay, so here, GSR. So that's our constant. Then we push AX, and then we send in 7 and go A to N. Okay, so 7 is our IP address then, right? Yeah, 7's is our pointer. So this is the pointer to the IP address, and then JSR LDAEXSP. Oh, curdly cripe. Just realized that. Yeah, I just realized that. That's not going to be good. I don't want to deal with that. Yeah, because although this is fairly good in a sense, which means that I don't need this to be a pointer. I would rather A to N be pointer based, because it makes the the assembly side much easier. Because if I send in a full 16-bit number into here and I have to store each portion, which makes it a headache, and I don't like dealing with 16-bit numbers on an 8-bit CPU. Sorry, not 32-bit number on an 8-bit CPU. That's definitely not something I want to do. So, yeah, let's do something else here. Let's do something different. So what I'm going to do is I'm actually going to make this a pointer and make this a pointer requirement, and then also, oh, I just realized this is bad. There we go. So yeah, because those are 32-bit numbers. I would rather C just handle that itself rather than me. So then I need to make this a pointer. Then, before I can do that, I actually have to allocate it. So IP equals IP address T allocate 4. Should be all I need for that. I think I can do size of IP address T, actually. I believe that's something I can do. I think. So let's make test2.s again. Okay, I've got a pointer that are cast on line 9 and line 14. So line 9, oh, that's why. Keep forgetting about that. And then line 14 here. Oh, that's strange. I wonder if that was just the result of the other. Nope, it's not. 14 still has an error. But that shouldn't bug out. Oh. Ah, yes, I see. Because I to A casting pointer to integer without a cast. Yeah, this makes it actually harder to code, because I to A now can't be done this easily. Not that I normally need to actually dump this out like this. It's only for testing purposes. It's not normal to dump that out. Casting pointer to integer. Actually, let me do a quick search here. Okay. Interesting. Yeah, 'cause there's no dereferencing required, it looks like, for this. Looking at dereferencing, the dereferencing option here. So I'm wondering if that's part of the problem, if I have to dereference it when I pass it through. Well, I guess I could write a small test program to see how dereferencing actually would work here. Because I could just create a regular integer, an int, a pointer to an int, and then determine how this actually functions. Because that would be that would be a good idea. That way I know if I'm actually doing this right. So new. Eesh. Yeah, I know. It's test after test after test. Okay, let's go test 3C. This one's going to be a very short program, though. Standard IO.h. Int main. Turn 0. Okay, so I'm going to create a pointer, an int pointer I. And then go I equals malloc 2. Memory allocation 2. Then go I equals and then 20. And then we're going to do n. We're going to need a small buffer. Buff equals char malloc 5 I to A. Okay, this will be a good test to see how that works. Line 11. It says converting pointer integer without cast. Okay, I get the same bug. But let's try running it and seeing what happens. So just as I thought. It says 819. Yep. So what I'm doing is that's a problem. Let's try this. That worked. Okay, so I do have to dereference it in C then. Okay. Perfect. That's what I expected. This was actually the address of the pointer in memory. This is the pointer itself. Okay. But But how come this works then? I'm worried now. I'm kind of wondering if something's going wrong here. Let's take a look at the memory dump again. So I just want to look in 300 and see if I can find 20. There it is. There's 20 right there. So if that's correct, that should be the integer that I'm wanting. Oh, but shouldn't there be two 20s? No. Actually, no, there wouldn't be. No, because that's the string version of it. That's not the pointer. It's the string version. So yeah, it's fine then. So this is 20 on the heap. Then I should see regular 20 as well. So I see this 20, and then I should see a regular 20. Oh, but it's going to be 32, I think, which is right here, because that's 20 in hex, I believe. So yeah. So it should be fine then. Okay. Yeah, this is interesting to learn. It's kind of easier to learn C when you actually know how everything works underneath. You actually tell how everything actually functions and works. So I'm not sure how this is exactly. Oh, I get it, because you're sending in the actual buffer. That's what IoT expects, right? I think I'm understanding this a bit better now. So let's go into here. Take a look at I to A. So this is the I to A function here. So as we can see, it takes the buffer in. So it's perfect. Okay, so now if I go back to my test2 code, I actually have to dereference it. So I do have to do this in order for this to work correctly. So I have to do *IP, dereference the IP address, and then I can do that. And this should now test2 should actually work. So let's build test2s again. Perfect, I got it. Let's go back to our source. Replace changes, yes. Okay. Now, if I look here, we're doing LDY. That, so we store that. Okay, here's our A to N now. So it's pushing so it pushes AX, which is this. And then here, it's that. So now there should be both pointers. So A and X should be the pointer I want, hopefully. So now we do A to N. A to N is what I was coding first, right? A to N, yep. A to N. Okay, so the first one is going to be the pointer to the last portion of our A to N call, which is the A to N. So it should be the IP. So I should have so the IP address is what I should have first. So I should have the IP address first. So in X. So if I go STA and then A to N. So numbers, the IP address, I want to store it. So destination would be actually, where's my IO? Oh no, I don't think IO. Oh no, IO API is what I want actually. I want to make sure this is consistent here. So where's my IO API? Include file. Where are you? So we need to do Oh yeah, actually I don't think I have that. Should be fine. Anyways, so F0 STX F1 JSR PopAX import PopAX, then STA F2 STX F3, and then LDA I put it as 40. And 41. Okay. So HE A to N. So HE A to N. And then store HE API. Right, yep, HE API, it's correct. And then it always returns 0 anyway, so I'm not going to bother checking in this. But yeah, actually that's all I have to do then, and just do an RTS. There's no need to set anything else because these variables will all be correct. And then technically all I have to do next is... I should just make a call for this actually. Yeah, Well, I guess I was hoping I could just, No, no. No. I know. Oh, yeah, okay, because it's one of those, oh, yes, okay. It's one of those kind of APIs. So I do have to run up here and then run down here. I can't just do an RTS here and do a jump up here and... Oh, shit. Oops. There we go. Yeah, I can't just go back and forth easily, so I do have to do like an RTS here. That kind of sucks. At least it keeps this code a little bit smaller. There we go. So that's the NetIO API. Yeah. Okay. Okay. So now let's rebuild our CLib. Make CLib is now built. Now let's remove test2.s, test2o, test2 bin. Okay, and then make test2 bin. Looks like it was fully successful. Okay, now for the test. Oh, that's weird. Why does it say 20? Okay, so something's going weird. Yeah, there's something going on here. Let me see what I'm doing here. Close that. Test 2C. So it is putting a buffer. It's doing puts buffer. So for some reason it's not giving me the number I want. Because A to N, oh wait a minute, I should check my my debugging output. Oh wait a minute, I know what's going on. I never restarted my VM daemon yet. So restart the daemon. There, it's restarted. Then let's try it again now. Still says 20. Okay. Do I actually? I should send debug output, don't I? No, I don't. Okay. So this is the one I want to test. So let's go log.debug HEI internal HE internal A to N API. There. Okay. Okay, doesn't look like it's being called at all, which is so strange. So, I'm not even sure why it's not even calling that API. So there's something going on here. HE, so LDA, so we're loading that into A, we store it. And we store it into there. And we store it into F2 API equals get IO F2. And then oh, I wonder now. I'm not doing an LDA. I think I have to do an LDA. I can set it, but then I have to do an LDA. Ah, yes, okay, I think I know what I'm doing wrong. I have to rebuild this, of course, now. I do have to do an LDA here. I have to reload it in. So now I have to recompile my there we go. Okay. Still says 20. But I got an exception. Critical server error exception. Value error. Invalid literal for int. Oh. This is correct though. 1, 2, 4. So that appears to be correct. I don't know why it's 3 there. Okay, the problem is that I'm not actually in my, because there's an exception in my API. It's causing the problem. An error occurred. Invalid literal with int 10. Oh, not this one. So yeah, it's this one right here. I want to comment that out for now. Still says 20, and I still got the same exception. So I still got the same exception, as you can see here. So that means that the code here is failing. Which could mean that it's not getting it correctly. IP address, get string address, ADDR. Huh. Yeah, because it's supposed to be zero. It's supposed to be 0 terminated is the incoming address. I'm actually going to do another memory dump. I just want to see what F0 is pointing to here. Or actually, I'll do it in game. Give an example of HEMON. Of course, it's not there right now. Okay. So 333. Okay, so 0333. 0333 0337. Let's go. Oh, that's definitely not an IP address. Or a string two, or a string of one. Oh, that's also weird. So apparently, this is at 3342? That doesn't appear like a valid pointer. Oh, no, that's in my... Huh. Okay, yeah, let's just do a memory dump here, because I'm now more confused than ever. There's something strange going on here. Okay, let's go back. Let's go to the 0 page first. Take a look at the 0 page. Yeah, there's something being written here. That's not it's not the IP address that I gave, is it? Let's find out. No, it's not. Shouldn't be. Okay. So now at F0, so right here, this is our kernel pointer location. This is 3342. That's not correct. Unless... Oh, that's weird. So this is F0, F1, F2, and F3. But F4 is also written. I'm wondering now, did I write my API incorrectly? 0, 1, 2, 3. Doesn't look like I did. But it almost seems like I did. Okay, let's go down into this page here and see. Yeah, I'm really confused here. So what I might end up doing is I might do a cgetc in my test2 code before I do any freeing or anything. Okay. So now what I'm going to do is I'm going to run it. Okay, now I'm going to do a memory dump. Let's see here. I might also stop and start everything too. Okay, so here's the proper addresses. This looks semi-right. Okay, so this is definitely different than before. Now it says 3233. Before it was 3233. It was. Really? Was I not looking in the right place? Oh no, I am. I'm looking in the wrong place. Sorry. I'm supposed to be looking here. In my new dump. I'm supposed to be looking over there. Okay, so here's my new dump. So I'm looking over to F. Okay. So this is the source, and then this is my destination. So destination is at D5A. Huh. That's a little weird. So this is what I'm storing in is 0D is page D5A. D5A. There's the there. Oh well, that is the IP address. So I think I'm setting it. I think I'm doing it backwards then. Yeah, I think that's what I'm doing wrong. But where's the 20 coming from? That's where I'm confused now. Okay, so let's go back in here. Let's go 2, 3, 0, and 1. Boom. Okay. Now let's rebuild it. Make test2 bin. Make test2 bin. Okay. Okay, here's test2 bin again now. Let's see if this works correctly. Still get 20. Huh. Why does it always want to give me 20? It's only 20. This time it should have changed if I changed the back-end code. You would think. So these two should be rotated, if anything. Yeah, it's rotated now. So now it's there, and then 3330. So now at 333, I should see... No, I'm seeing not that. 1, 2, 3. Unless I'm looking at the wrong place. Let me see here. Okay. Oh, no. Where is it? Okay. So 0, 3, 0, 3, 33. 0, 1, 2, 3. So this is what it's writing in it. This is what it's writing in, it seems. But that doesn't appear correct. Is that what happened before? 140009. But then it should have overwrote the other one then, but it doesn't. It's the exact same thing. So it's not writing, it's not putting anything there as it should. Did I write the API incorrectly or something here? Ay, this is getting a little too much. 10003 Puppy X. What the heck is going on here? Let's go back to my API again and take a look here. Okay, so F0 should be the pointer to the address I'm trying to change. Let me double check here. So F0 should be a pointer to the address I'm trying to change, right? Yeah, so F0 it's 0D5A, and that's an address within the code. So that's correct. So this should be the address I'm trying to change. I'm trying to convert over. It should be the string. Yeah, I'm doing a get string. Okay. So then we do a get string for that address. So now we should have. This should now work. Let's find out actually. Let's do this first. Nope. I'm still getting an exception, which is why this is breaking. I'm still getting an exception here. For some weird reason, there's an exception happening, and it's the exact same one as before. Where it goes server exception. It doesn't get the IP address correctly, which it should. Because, oh, wait a minute. It's not a pointer. I just realized that. Because F0 is not a pointer. It goes directly to it. That's how it's sending it in. That's the problem. So I need to go get string 0xF0. That's my problem. There we go. Okay, now let's try running it again. Oh, come on, really? I'm still getting the exact same exception, except now there's a Z in the front. There's Z's like, what the, come on. Oh, that now should have worked. Because now the IP address is this. But how am I doing this? I guess no get address and self.get actually does self.get actually. Where is self.get? I'm starting to get frustrated. Okay, because it's the okay, that's why. Because I'm trying to get the page. Actually, no. This only. Okay, if page in. No, that shouldn't actually do that. This should be fine. It should just get the 0 page yeah, it should just get the 0 page because the page is not in there. The page is going to be 0. So it should just be going through here. That is rather frustrating now because I don't know what's going on then. And it still gave me a weird error because now IP address should be the mem of get string. Oh, no. Okay, no, I know what's going on here. But why would it give me that though? Okay, so address, this is our string address, and then IP address should be get string of our address. That is correct. That is correct. Because we want to get a word from here. Because at F0 0 is our D address. And then we're getting our string. Which should be our string. Because at F0, when it dereferences that, it goes to 0D5A. And we go up to 0D5A, right? 0D5A, we have our address. We have our IP address starting here. But, oh, wait a minute. It might not be. It might not end in a 0. But D5A. This is interesting now. But where's it getting that other weird code though? This should be A here, I think. Right? 0, 1, 2, 3, 4, 5, 6, 7. Oh no, that's 8. 9A. That's A there. Which is 32. Is that a 2? No, this is completely wrong. It doesn't start until up here somewheres. This is A here. 8. 1, 2, 4, 5, 6. No, I guess that's right. Yeah, that is correct. Okay, so it's correct. And then we resume on the next line. And then there's our 0. This is where our 0 is. Yeah, that is right. So this is our null. And that's the rest of the IP address. So then why doesn't that work then? Because we definitely dereference it here. So we go mem self.mem.getString. Oh wait. Oh no. Oh no. Oh wait. That's why it's messing up. I know why it's messing up. Oh no, I just realized that. Okay. But then F2 can't be that. Oh no. How did I not see that? It's supposed to be F0 and F3. Oh no. Ay, ay, ay. All of this troubleshooting, and I just realized what the problem was. Okay, now I know what the problem is. Okay, if I actually go to my I/O API, I'm kind of wondering if I'll notice it here as well. No, I don't have it listed in here. I don't have it listed. Ha ha ha. Okay. You guys understand now what my problem was? Oh, I can't believe that I did that. Now I'll get it working. All this, how long was I troubleshooting this for? Oh no, it's just horrible. Anyways, now that I know what the problem is, now I can at least set this right. So HEPTR2 HEPTR2 plus 1 HEPTR1 HEPTR1 plus 1. There we go. Problem solved. I seriously can't believe it. That is so frustrating that was the entire problem. Okay. Okay, now I got my test tube in again. Now this should work. There. 3744 should be correct. Let me look at here. Okay. So the HE internal API works now, as we can see here. So we have this. We got the IP address, and it set it this way. So now, oops, actually I'll keep this here for a second, for we can confirm that we have it in our heap now. So now if I go to 3, I should see it in my heap. And there's our buffer. Okay. Let's get the heap address again here. So our destination is at 0. So it's 30, same heap address. That's predictable. It's good to know though. Okay, so this should be our encoded IP address. Let's find out if it is. Oop, actually, let me highlight that again. Oh. Okay, so we're going to go into hex, and we're going to go 18 decimal 24. Yep, I think that's it. Clear 78 decimal. Huh? Okay. Oh, I put a C there. Where's the clear on this calculator here? I don't use GUI calculators very much. I usually use Python as my calculator. Yeah, where is clear? Let's do that. 78. 120. Yeah, that's the address we're expecting there. Okay, so it looks like it's fine. The only weird problem is that it's not displaying it on the screen correctly, because I get 3744 as my integer. Maybe that is correct, but it doesn't sound like it's correct. Sounds a little low. It does sound a bit low. Let's look at my code for 1 second, just determine if that's correct. But so now this function is working correctly. The only problem, oh no, sorry, not that function. This function is working correctly. Because now it's actually placing it in the correct place. The only problem is I'm not sure this is working correctly. Looks like it should be, though. 30744 doesn't really seem correct, though. It really doesn't. So socket dot inet a2n 24.120 dot 43 dot 89. Okay, so that's nope, it's the same regardless of sign or unsigned, so it's not the right number then. I wonder if for whatever reason it's just a little too small. Yeah, because that number is way too small. It almost seems like it's only the 16-bit version of it, which now makes me wonder if I to A. Oh, there we go. So if I go to the I to A function, oh, that's why. I'm using the wrong one. I need to go UL to A. UL to A. Because unsigned long. Or, oh. Uh-oh. I just realized something here. Yeah, it's unsigned long. Yeah, unsigned long. Okay, that's fine. So unsigned long to A. Okay, now let's try compiling it again. Now it should give me the correct answer. That looks right to me. Ta-da! It worked. Look at that. Beautiful. Okay, now let's try to convert the other way around. Okay, so this is test 2. Now I want to get rid of C get C. I want to go C put C, and then I'm just going to put enter there. And now we're not going to free the buffer or anything yet. Ooh, I guess I do need to free this though. Yeah, I guess I need to free that eventually. Okay. Luckily, the memory allocation doesn't go through the kernel yet. I might do that eventually, where malloc goes through a kernel call to allocate memory, but right now it's not. So I don't have to really worry about memory leaks yet. But I will if I want to do multitasking, because each C program having their own heap wouldn't work very well. If I should be able to properly do stuff, I'm going to have to do that. Anyway, so with that working, now we have a buffer that has, so now we need to do an N to A, IP, comma, IP, comma, and then we want we actually would need a new buffer, a new character buffer, buff2. Okay, and then we go buff2 equals malloc. Let's do actually 20 should be fine for that, right? Okay, and now buff2 should have the IP address. So puts buff2 and then free buff2. Okay. This is going to be a bigger program, but let's find out if it actually even builds it. Ooh. I got a couple errors, but I think I know. So undefined function, oh yeah, bleh. I spelled it wrong. That could be part of the problem, though. Nope. Converting cast load pointer. 19, 20, 21, 22. Oh, wow. So 19... Huh? Really? 19 warning. Convert pointer to integer without cast? No. Yeah, apparently line 19, converting pointer to integer without cast. But it's the same as this line. How is that possible then? That makes no sense. They're the exact same line. I'm doing the exact same thing on just two different buffers. So I don't see why it would say this at all. Converting pointer to integer without cast. Huh. And this one's convert integer to pointer. Integer to pointer without cast. Well, let's just try running it just to see what happens. It worked. It did convert it back. So it converted it both directions like I expected. But I just don't like the warnings though. The warnings aren't really good. Convert pointer to integer without cast. Convert integer to pointer without cast. Convert integer to pointer without cast. It's like everywhere. It's like, oh, wait a minute. Oh, wait a minute. I think I know why. Apparently, you have to do that, I believe. Yep, that was the problem. So I'm surprised that code even ran. But it did. And it still runs. Yep, perfect. Yep, it works. So both directions works just fine. So now we can do the A to N and N to A perfectly. Yay! Awesome. So with that, I think I might actually get something to eat right away then, because I'm kind of hungry. So then when I get back, I can work on the net on the Echo client that I was originally going to write. I never started writing it all yet. So, but yeah. Okay. Let me see. Let me look at the